Hello friends, myself Dr. Lalit Gupta, Assistant Professor, Department of Computer Science and Engineering. My specialization in grid computing, distributed system and cryptography network security. Now, I am teaching you the concept of distributed system, a open elective subject of 8th semester BTech Computer Science Engineering 4407. Today, in this lecture, I am teaching you the introduction to the distributed system. This subject is taught in 8th semester of BTech Computer Science program, whose syllabus is displayed on the screen. There are total 15 lectures covering the different topics. First one is the introduction to the courses. Second is the characterization of the distributed systems, system models covering the architecture model and the fundamental models of the distributed system. Then next one, networking and internetworking, covering the concept of elementary concept of networking and internet. Then we will cover the inter-process communication, IPC, including the intra-process communication also by the message passing. Then fifth, we will cover the remote invocation method, including the RPC based on the Java RMI and Java RPC. Then we will cover the indirect communication, the basic concept of operating system needed for the designing to the distributed system. Then we will go on object oriented concept for the distributed system, distributed objects and components. Then we will cover the web services, elementary web services provided on the internet, how we will use on our distributed system. Then we will cover peer-to-peer system. Next one is the security, in how we will implement the security parameters in distributed system to secure the system, like X.509, Kerberos and so on. Then we will cover the architecture of the distributed files system, covering the Sun network file system and Andrew file system, AFS both. Then we will cover the name services, covering the domain name system, global name system, X.500 standards, Gini, LDAP also. And last one, we will focus on a case study of the CORBA, Common Object Resource Broker Architecture. Now, these are the sources which I have used for making the slides. The first one in the textbook for the subject distributed system concept and design by the George Corliss, Jean Dollimore, 5th edition. And as you are seeing in the hyperlink, the green in the blue symbols, the additional reading that are available on the net, like Java Ideal, NFS version 4 protocol, CODA file system and so on. Now, we move on the concept of distributed system. A distributed system is one in which we communicate and coordinate their action by passing the messages. Passing the message is only the method to synchronize our events used for coordination in the distributed system. A clear definition about the distributed system can be given by: a distributed system consists of a collection of autonomous computers linked by a computer networks and equipped with distributed system software. This software enables computers to coordinate their activities and to share the resources of the system, hardware, software and the data. When we have studied in the 6th semester the computer network, I am focused on the differentiation between a network and the distributed system, as the collection of the autonomous system which are interconnected is called computer network, and distributed system is defined as the resources which are geographically distributed over the globe, but seems to be a single autonomous system. Here resources, computing resources are not put together on a single place. Actually, they are distributed beyond the timelines on different geographical territories. When we are making a distributed system, then there are some elementary problems which may occur as we define the concept of distributed system. Here we have listed 3 major problems. First one is the concurrency of components. In a limited network such as we have studied the LAN, WAN, MAN, we can remove the concurrency problems by shortening some implementation of parameters like semaphore, critical section and so on. Here the concurrency problems is beyond the limited territories, it is over the globe or beyond the some particular geographic territories. So, it seems to be a large problem for the synchronization of the accessing of particular resources to, so that we can support concurrency. Second is lack of global clock. As we know, there are different timelines in the world which shows different real time of different regions. There is no notation of a single expression of times which will be the same. Even there is some difference between the clocks in form of clock drift, in form of clock skew and so on. So, in the absence of global clock, we are unable to synchronize the events on the basis of the times. For this, we have to launch a different time notation like Lampert clock, that is a logical clock, or implementation of vector clock which gives the logical times which are used to synchronize the events. Here third is independent failure of components. In distributed system, any component can fail anytime. To minimize the effect or recover the effect arises due to the faults, we have to design distributed system in such a criteria that we can bear independent failure of components. Or we can imagine a situation, you have a distributed system. When the crash of a computer, you have never heard of stops you from getting any work done. There should be no effect of failure of one component in a distributed system. There should be some replica or instances of the resources that may act as a original one. Actually, there is no difference between the original one and replica, but that can provide the resources after the crash of one resource provider. The prime motivation behind this is to share the resources. Now, what are the challenges for designing a distributed system? To design a distributed system, there are various challenges. First is heterogeneity of the components. We can define distributed system as a network of the network. In fact, internet is the biggest example of the distributed system. There exists heterogeneity in many forms. In forms of developer, in forms of implementation in different programming languages, in form of heterogeneity of machines, heterogeneity of the operating system, heterogeneity of the network, and so on. There are various type of heterogeneity occurs in different networks, and we are creating a distributed system by interconnecting these networks. Second is openness. Our distributed system should be open so that anyone can interact easily with the distributed system. The interfaces should be published, methods should be publicly available to access the resources. Third issue is the security. Our distributed system should be secure to encounter various attacks that may possible in a distributed system. Scalability is the different issue for designing a distributed system. As load varies depending upon the need, we can expand or shrink our distributed system. Next one is failure handling. There should be some efficient mechanism for handling the failures, from identification to marshalling, masking, unmasking, and from the steps of the recovery also. Concurrency of components. Components can work efficiently in concurrent manner to provide the resources. Transparency. Transparency is also the biggest challenges for the distributed system. There are our distributed system should support various types of transparency. Transparency in forms of location, access transparency, and so on. Last one is the providing the quality of services. We are designing a distributed system to provide the resources to the user. The performance of distributed system should be maintained up to the some level. So the quality of the service is again very important parameter. Now we will study the example of distributed system. Here we are seeing a table describing various applications that depends upon the distributed system. For example, in the field of finance and commerce, e-commerce applications like Amazon, eBay, PayPal and online banking, such type applications are example of the distributed system. In the area of finance and commerce, the information society, the information available on the web through the search engines, e-books, Wikipedia, social networking sites, Facebook and so on. These are the various example for the information society. These are also the example of distributed system. Creative industries and entertainment, online gaming, music, film in the home, video on demand, user generated content, famous one is the YouTube. These all distributed application lies in the sector of the entertainment, healthcare, all the health informatics, all the types of health informatics such as online patient records, monitoring the patients. In field of education, various e-learning portal or that creates the virtual environment for e-learning or distance learning. These all are example of distributed application in the field of education. Transport and logistics, all the transport and transportation applications which are supported by the GPS for finding the routes, Google Map and some satellite imagery applications such as Google Earth. These are the example of the transport and logistics. In the field of science, the grade is enabling technology in various scientific applications. Grid computing is an example of distributed system. Cloud computing is an example of distributed system. And last one is the environment management, various sensor technology to monitor earthquakes, floods, tsunamis and so on. These are the applications for the distributed system. Now, these are the examples for the distributed system. वेब सर्च का गूगल है and so on. This is the example of financial trading, distributed event based system. Here we are showing a Reuters market data events, fixed gateway is interacted by the fixed adapter that interact with the complex event processing engine that interact with the Reuters adapters, Reuters gateway and that are the supported by the Reuters events. Now, trends and distributed system. Emergence of pervasive network technology. As such, technology is changing, its effects our distributed system, so that any centralized monitoring system to up to the using the grid computing to the cloud computing, our technology differs as the technology changes. Second was the example of the ubiquitous computing. Spontaneous computing is another utility based computing applications are also example of the emerging technologies for the distributed system. Various multimedia services or distributed systems such as utility services. These are the examples for the various pervasive technologies. Now, the figure shows a typical portion for the internet, from a local network to using the we have created a internet using the local networks that interact with the internet service provider ISP that is connected by the backbones. This is the elementary diagram for an internet. Second is mobile and ubiquitous computing is the another example for the distributed system. Some handheld devices, laptops, palm tops or wearable devices used in different home appliances or business appliances creates a mobile and ubiquitous computing form. Another example for distributed system. Portable and handheld devices in a distributed system and ubiquitous computing that creates an home internet that is supported by the internet. Here are the this picture shows all the three examples for the distributed system: internet, and ubiquitous computing. Distributed multimedia systems, television broadcasting, ordered or pre-ordered, live telecast or pre-ordered telecast, both covered by the distributed applications. Video on demands is another example from distributed multimedia systems. Music libraries, audio and video conferencing is the example for the distributed multimedia services. This is an diagram showing the distributed computing as a utility services covering the both elementary technology, cluster computing and grid computing. And now at this age we are lying in the age of cloud computing. There are various utility services like application services, storage services, computational services. Clients are interacting these servers through the internet. These three services mainly we have studied in cloud computing as IaaS, PaaS, SaaS, infrastructure as a service, platform as a service, and software as a service. This is the example for the cloud computing infrastructure. Now, Mainly we have designed the distributed system to share the resources. These resources may be hardware resources or the software resources. Software resources may cover the database, properties, software, software production or collaboration of the softwares. Different resources are shared in different ways. For sharing these resources to the users, we requires elementary three things: a namespace, so that we can identify the objects which we have to share; name translation to network address, we can translate the name of the objects to the network address, such as in the internet we have used ARP, address resolution protocol, and reverse address resolution protocol, RARP. And last one is the synchronization of the multiple access. We have to synchronize the multiple access of the accessed resource. Now we are again focusing on the challenges for the distributed system which may occur for when we will design a distributed system. First one is the heterogeneity. Heterogeneity exists in different ways. Heterogeneity may occur due to different networks, due to different computer hardware, due to different operating systems, due to implementation in different programming languages, or implemented by the different developers. These are all the forms due to which there exists a heterogeneity in our distributed system. Now, to remove the heterogeneity in distributed system, we used a middleware layer that works between the application and the platform. So its name is the middleware layer. It's provide a virtual environment to run a distributed application over the different networks. To remove the heterogeneity, we have used mobile code and mobile agent. Mobile code are the codes that can run anywhere in any machine, and the mobile agents are the specific agents that can carry the mobile codes from one machine to another machine. Our distributed system should be the open. The openness of a distributed system means our system can be extended or re-implemented in various ways. We can add a new resources that can be shared on the distributed system for the variety of the users. To support openness in our distributed system, we need a uniform communication mechanism. In fact, we are using the only one method for synchronization purpose, that's a message passing. Second is published interface to share resources. Each resources that has to be shared in a distributed system must publish its interface to the users, so that the any user on the distributed system can access that resources using that published interfaces. Or whenever we are publishing an interface, a method, a mechanism that should be tested and verified by the system that it is working correctly or not. Third one is the security. We know about the CIA triad: confidentiality, integrity and availability, and all the three A's should be exist in our distributed system, so that we can challenge the security attempts, such as famous one is the denial of service attack that exists in the forms of distributed denial of attack, security of mobile code. Mobile codes are important issues for the security concerns. Now, our distributed system should be scalable. As the load varies on our distributed system, our distributed system should work in an efficient manner. When we are designing a distributed system, we have to consider the 2 points: how to control the cost of physical resources. Second one is controlling the performance loss. The resources must be sufficient to handle the request, so that the performance cannot decrease beyond the some particular critical level. This is the avoiding the performance bottleneck. An important challenge for the distributed system is the failure handling. Our distributed system must incorporate various techniques for dealing the failures, such as detecting failures, where the failures occurs, masking failures, which type of failures occurs. Third one is tolerating failures. How can we avoid the fault that is occurred in the distributed system? And last one is the recovery from the failures. How can we recover from the effects that are arised due to the failure? Redundancy is an important method to avoid the failure. We use redundant components, means we will always implement at least 2 different routes, and like in similar to domain name system, we use the multiple instances for the resources, so that in case of failure we can provide the resources from the another instances. We have already discussed about the concurrency issues, and last one is the important parameter for the transparency issues. Our distributed system should be transparent to the application, to the users also. There are different forms of transparency that must be present in distributed system. First one is the access transparency. there should be such mechanism to access the resource in the similar manner. Either it is we are using the resource locally or remotely. I mean, there should be no difference between the access of a local resource and the access of the remote resource. Second is location transparency. There should be mechanism, we have to develop mechanism in such a way we can access a resource without knowing the location of that resource. Means mechanism should be the location transparent. Resources may be in some other territory, location may be in some different territory, maybe different networks. That is transparent. Concurrency transparency. Any resource will be available to the user in similar way, similar fashion. Either it is demanded by a single user or it is demanded by the multiple users at the same time. Replication transparency. I am already discussed. We will use a multiple instances or replicas for a single resource. The resources is provided to the user by the original one or the replica one. There should be no difference. In fact, for nomenclature purpose, for identification, we are saying that this is the original, this is the replica. There is no difference between the replica and the original one. As such, original server will provide the resources in same manner, same fashion. The replica will also provide the resources. Failure transparency, that is also defined as fault concealment. The resources should be provided to the user in the same manner as before the fault occurs or after the fault detection or recovery, in the same manner. There should be no effect of failure in the distributed system. Mobility transparency, the resources will be provided to the user, either the user in the lying in the static single location or changing its location to the different places. Now, last one is the quality of services. We are designing a distributed system to provide the resources. So, the important parameter is the quality of service. The quality of service can be measured in three dimensions: reliability, security, and performance. Quality of service should be maintained in distributed system. And a case study for a distributed system is the example of World Wide Web is an famous example for the distributed applications. We have studied in previous semester also. We will study in later recorded lectures also. Okay. Thanks. We will in another lecture we will cover the architecture or model that will be used in distributed system, such as architecture model and fundamental model. Thank you.